All right, so in this unit, we are going to talk about nuclear reactions. And nuclear reactions are changes that take place in an atom's nucleus. So before we can really get into what kinds of changes happen in an atom's nucleus, we need to kind of get the common language together. So today we're going to talk about what are called isotope symbols. Now we've talked about isotopes before, way back when we were talking about atoms. But let's kind of refresh what we know, and then we'll talk about how we name these isotopes, and we will talk about isotope symbols. And our target is to be able to read and interpret isotope symbols. So let's go ahead and talk about some of that stuff. Okay, we spent a lot of time at the beginning of the class talking about what an atom looks like. What different particles do you find? Where do you find them in the atom? Just as a kind of review here, in the nucleus of the atom, in the center, you find two different kinds of particles, protons and neutrons. And I've drawn here black circles to represent protons and pink circles to represent neutrons, because pink is the only other color marker I have, so black and pink. And then we also learned about a third type of particle, the electron, that is not part of the nucleus. And you can see I've drawn here dots to represent electrons outside of the nucleus, right? And we have in our class talked extensively about what happens with the electrons. When atoms gain or lose electrons, or they share electrons, you have a chemical reaction. This unit isn't about chemical reactions. This unit is not about the electrons. This unit is about nuclear reactions. This unit is about what happens when changes happen to the nucleus. Okay, so we have protons and neutrons in the nucleus, right? And we've learned that you can tell which type of atom, which element is this, by how many protons there are in the nucleus. So if you count my black circles there, the protons, there are 6 of them. And if you look to the periodic table, you find atomic number 6, and atomic number 6 is carbon. So I know this particular type of atom is a carbon atom, right? Do the neutrons tell me anything about what element it is? No, it's the protons that tell you which element is this. This is a carbon atom because it has 6 protons. Okay, now a carbon atom always has 6 protons, but you can see the one I've drawn has also 6 neutrons, 6 pink circles that I've drawn. A carbon atom does not have to have exactly 6 neutrons. It could have more neutrons, it could have less neutrons. It could have different numbers of neutrons. These are called isotopes. This particular isotope of carbon has 6 neutrons. Another fairly common isotope of carbon has 8 neutrons, right? They're both carbon, they both have 6 protons, but they have different numbers of neutrons. These are isotopes, right? And we usually use particular symbols to talk about isotopes. So for this particular isotope of carbon, what I would do is I would put C for carbon, I would put the element symbol, and then in the bottom corner here, the bottom on the left-hand side, I'm going to put the number of protons. Carbon always has 6 protons, so we'll put a 6 there. On the top, I'm going to put the total number of particles in the nucleus. So that's how many protons and neutrons together. Okay, so this particular isotope of carbon has 12 protons and neutrons together. This is called the mass number. This one's called the atomic number. Okay, and we've learned these before, right? So this is what we call an isotope symbol. Now, to name the isotope, what we usually do is we'll name the element. So this is carbon, and then we will include the mass number. So this particular isotope of carbon is called carbon-12, right? Sometimes you can abbreviate it with just the element symbol and the mass number, and people will know you're talking about carbon-12. Let's say I had a different isotope of carbon. Let's say I had 2 more neutrons in there. Okay, now what would this look like? Okay, well, is this still carbon? Yes, it is. There are still 6 protons. This is still carbon. So the atomic number that goes on the bottom here is still 6. Carbon will always have 6 protons. So that bottom number will always be the same for carbon. But now the top number, how many different particles, how many protons and neutrons together are in the nucleus? Now there are 14 total, right? There are 6 protons and there are 8 neutrons in there now. So the total number of particles, the mass number, is 14. Okay. What would I call this isotope of carbon? This is not carbon-12 anymore. Now this is carbon-14. And you could abbreviate it C14. Let's say I'm given the name of an isotope. Can I write its isotope symbol? Can I figure out how many protons and neutrons are in the nucleus? Let's see. So here I have an isotope, uranium-238. Let's write its isotope symbol. Well, first let's find uranium on the periodic table. Here's uranium. Uranium's atomic or element symbol is capital U. And its atomic number is 92. So this number on the bottom here should be 92. Okay. What number goes on top? The mass number, which is easy because it's part of the name. You see 238 there? That is the mass number. So here we have the isotope symbol for uranium-238. Let's say we want to know how many protons are in the nucleus. Well, that's extremely easy. It's part of the symbol there. We've already looked it up. It's the atomic number. There are 92 protons in an atom of uranium. Let's say we want to know how many neutrons are part of that specific isotope. How many neutrons? Well, it doesn't say in the name. It doesn't say in the symbol, but this is the number of protons and neutrons together. This is the number of protons. So if we subtract those two numbers, we find the number of neutrons. So I'm going to take 238 and subtract 92. So there should be 146 neutrons in that particular isotope. So if we know just the name of an isotope, we can find all this other information about it. One more thing I want to say about isotopes. All isotopes contain protons and neutrons in the nucleus, but nature only allows certain combinations of protons and neutrons. This particular isotope, notice I haven't drawn the electrons. I've only drawn the nucleus because I'm not interested in the electrons here. We're just interested in the nucleus. This particular one, if you look, I have 3 protons and I have 4 neutrons. So because it has 3 protons, this is lithium. And because there are 7 total particles there, this is a lithium-7 nucleus. Okay. This is one of the combinations of particles that nature allows to be in a nucleus. This is what we call stable. Okay. That nucleus can exist for a long time, forever, indefinitely, right? This particular nucleus is different. Notice I still have 3 protons in there, but now I have 5 neutrons. This, because it still has 3 protons, is still a lithium atom. But now there are 8 particles in that nucleus. This is lithium-8. This is not one of the combinations of particles that nature allows. This can happen, but it's what's called unstable. This nucleus will eventually fall apart, right? It cannot exist indefinitely. So one combination of particles can exist indefinitely. We call it stable. One that can't exist indefinitely is unstable. That nucleus will eventually fall apart. And that's one of the kinds of nuclear changes that we're going to talk about in this unit. So there's a little bit about isotopes, a little review about isotopes, what they are, what kinds of particles you find there. little bit about isotopes names and isotope symbols. That should help us to be able to read and interpret isotope symbols. So, till next time.